Quantum chess is a combination of chess with the rules of quantum mechanics. The initial position is the same, but for every conventional chess piece, there is a corresponding pair of indefinite pieces, one piece with a red mark in it, and another piece with a blue mark. Indefinite pair instances on the chessboard represent the spatial superposition states of corresponding conventional pieces. The superposition principle for all linear systems is the net response caused by two or more stimuli and the sum of the responses that would have been caused by each stimulus individually. For example, the rolling motion is the superposition of two motions, the translation without rotation and the rotation without translation. The stimuli are vectors or vector fields, and the superposition is the vector sum. This is an example for a superposition move. The knight, the conventional piece, is replaced by two pieces of a corresponding indefinite pair instance. Two indefinite pieces are paired. They represent the conventional piece in a superposition state of being on two squares at once, e4 and e5. If both marks point to the same direction, it is called an equal superposition move. In this move, the two marks face opposite directions. This makes the move an unequal superposition move. The player making the superposition move can really choose either of the two options. A capture move in which at least one indefinite pair instance is involved is called an attempted capture. The rook on e6 and e4 is attacked by the f5 pawn. As the pawn arrives on e6, the outcome of the capture is determined by rolling a six-sided dice. Each player with an indefinite piece on the targeted square randomly collapses their corresponding indefinite pair involved by rolling a dice. Rolling an even number 2, 4, or 6 collapses the pair to the square where the indefinite piece with the red mark stands. Rolling an odd number 1, 3, or 5 collapses the pair to the square where the indefinite piece with the blue mark stands. In this example, black rolls a 3, which collapses the indefinite pair to the e6 square. After the collapse, the rook becomes a target for the white pawn and is captured. In this position, the capture of the knight on d4 is forbidden. The knight could collapse to e5, which would put white king in check. The black king on g8 is exposed to an indefinite attack. This is a checkmate because no move can guarantee the black king to get out of it with certainty. Like in conventional chess, a move that could potentially expose the own king, indefinite or not, is not allowed. In this example, the knight on f6 joins the superposition of white's indefinite rook on e4. All the participating indefinite pieces must be oriented such that their marks lie on the same diagonal, and each pair must indicate the same type of superposition, equal or unequal, as the targeted opponent's pair originally indicated. Indefinite pairs instances with marks on the same diagonal are entangled. After joining the superposition, the marks are aligned on the -45 degrees diagonal. On the chessboard, there can be a maximum of two entangled groups because a square has only two diagonals, +45 degrees and -45 degrees. The bishop on e2 can join the superposition and attack the knight by moving to c4. All marks stay aligned on the -45 degrees diagonal. The picture on the left shows quantum entanglement. The photons are entangled. Their properties are dependent from each other. That's why only the orange or magenta detectors can react, but not both at the same time. The picture on the right shows the classical models. All detectors can react anytime if the photons are not entangled and independent from each other. Entangled pairs collapse together. The white rook attacks the knight on f4. Black rolled the dice to an even number, which resulted in a collapse to the red marked positions. The black knight escapes. The black king on e5 is in check by the white queen. However, black can entangle its king with the white queen. That allows the black king to escape the check. In classical chess, the knight is allowed to jump over other pieces. In quantum chess, quantum tunneling is allowed for the conventional pieces. The involved pieces must be of different color, and quantum tunneling is only allowed if the player rolls a dice with an even number. If he rolls an odd number, the piece stays where it is. Quantum tunneling is only possible to the square right behind the opponent's piece. It has to be unoccupied. Quantum tunneling is a unique quantum mechanical phenomenon. An electron or atom can go through a potential energy barrier even if it doesn't have enough energy to pass or surmount the barrier. The tunneling effect is, for example, important for electronics and nuclear fusion. Classical physics cannot explain quantum tunneling. Quantum chess is a nice example for understanding the fantastic phenomena in quantum mechanics. Check out the link to the scientific article in the description field. Thank you for watching.